Identifying what is happening in oxidation reduction reactions is pretty straightforward when you're dealing with ionic compounds because you know the charges of the ions and you can track what is happening with electrons. But what if we have reactions containing covalent compounds that consist of nonmetals bonded to each other? How do we track electrons in these covalent compounds? Well, chemists have come up with a way of doing this electronic bookkeeping by using what are called oxidation numbers. So in this video, I will be explaining how we assign oxidation numbers and some examples of compounds where we will be practicing assigning oxidation numbers. So there are a few rules that come into play when it comes to assigning oxidation numbers. Hopefully these rules aren't just random rules that you have to try to memorize. I hope they make sense to some extent. So first of all, let's start with what do we do if we just have an element? It could be a monatomic element like copper or a diatomic element like fluorine. Both of them are assigned oxidation numbers of 0. So the copper has an oxidation number of 0 and the fluorine has an oxidation number of 0. The next rule is if we have a monatomic ion. For example, magnesium ion has a charge of positive 2. The charge of that ion is its oxidation number or its oxidation state. That should be pretty easy because you can see the charge written next to that element because that's how we represent ions. The next two rules have to do with hydrogen and oxygen. Usually, hydrogen will have an oxidation state of positive 1, and oxygen will have an oxidation state of negative 2. If we look at water, we can see these oxidation states. We have 2 hydrogens and 1 oxygen, and both hydrogens will have positive 1 oxidation states, and the oxygen will have a negative 2 oxidation state. The next two rules can easily be displayed in the compound sodium chloride. So elements in group 1 are going to have a positive 1 oxidation state when they're in compounds. Elements in group 2 are going to have a positive 2 oxidation state when they're in compounds. The halogens will usually have a negative 1 oxidation state when they're in compounds. So in sodium chloride, sodium will have a positive 1 charge and chloride will have a negative 1 charge. Now I say the word usually when I talk about the halogens having a negative 1 oxidation state, and this is because they usually do have that oxidation state, but sometimes they can have different oxidation states. So I try to keep assigning the oxidation states of the halogens until towards the end. Now, as you saw with the water, with the H2O, if we add the oxidation states of the elements in a compound, in a neutral compound, the sum of all of those oxidation states will be 0. So in that water, we had 2 hydrogens with a positive 1 oxidation state and 1 oxygen with a negative 2 oxidation state. That means if we add these two numbers up, we will get 0, and water is a neutral compound. It's a neutral molecule. Now, if we have an ion, the charge of that ion will be the sum of all of the oxidation states of the elements and the atoms in that polyatomic ion. So if we have something like SO4 sulfate with a negative 2 charge, we know the oxygen is going to be negative 2, and there are 4 oxygens in this polyatomic anion. So if we have 4 oxygens with a charge of negative 2 each, the total charge of all of the oxygens is negative 8. But the charge of this ion is negative 2. So we have to use a little bit of algebra to figure out the charge or the oxidation state, the oxidation number of that sulfur. So if we take sulfur's oxidation state plus a negative 8, that's the oxygen oxidation states, we will get a negative 2. That's the charge of the overall ion. That makes sulfur have an oxidation state of positive 6. So pause the video and practice assigning oxidation states to each of the elements in these compounds. All right, so the bromine, this is an element, it's a diatomic element, so the oxidation state will be 0. Now we have carbon monoxide. Let's assign oxygen's oxidation state as a -2. We know this is a neutral compound, so carbon's oxidation state will be +2. Here we have a polyatomic anion, phosphate. We know that oxygen is going to have a -2 oxidation state. We know there are 4 oxygens, giving us a total of -8 just for the oxygens. But the overall ion charge is a -3. So that means that the phosphorus is going to have a +5 oxidation state, because 5 plus a -8 gives us a -3. Now we have sodium, chlorine, and oxygen all in this molecule, and it's a neutral molecule, a neutral compound. So we have the oxygen is going to be a -2, and there are 4 of them. So that gives us a -8. The sodium is going to be +1. So that means that our chlorine is going to have a +7 oxidation state. In this carbon tetrachloride, we have chlorine and carbon. I'm going to assign the chlorine with a -1 oxidation state, and there are 4 of them. This is a neutral compound, so the carbon has to have a +4 oxidation state. Now we have nitrate. Oxygen has a -2 oxidation state, and there are 3 of them. The overall charge of this ion is -1. So just in our oxygens, we have a -6 oxidation state. The overall charge is -1, so that means that that nitrogen is going to have a +5 oxidation state. Now let's take a look at a couple redox reactions containing covalent compounds. We will assign oxidation numbers and then determine which element is oxidized and which element is reduced. So let's take a look at the carbon. This is a neutral atom, and it's an element, so the carbon is going to have a 0 oxidation state. The sulfur will also have a 0 oxidation state. Now if we look at the products, this carbon disulfide. So in this, we're going to assign a -2 oxidation state to sulfur, just because carbon tends to be a little wishy-washy. Sulfur's usually going to be a -2, depending on what it's bonded with, but in this situation, assign carbon last. So we're going to look at the column that sulfur is in. We're going to assign a -2 to the sulfur. This is a tricky one because I don't have a rule on sulfur, but when in doubt, look at what charge it would become and try to assign carbon last. So sulfur is going to have a -2 oxidation state. There are 2 of them. This is a neutral compound, so that means that the carbon is going to have a +4 oxidation state. So the carbon is going from 0 to +4. That means the carbon is being oxidized. The sulfur is going from 0 to -2. That means that the sulfur is being reduced.